We are going to welcome our next panel. Our moderator is Lydia Fletcher from the Texas Advanced Computing Center. And then we have Tomislav Urban, Pavel Mishtel, and Casey Faust. And they are going to share with us some case studies from Planet Texas 2050 tools and analytical processes that the Texas Advanced Computing Center have set up throughout the process of the course of the past 8 years, and we'll have time for questions. I'll pop back up here and circulate with this when it comes time for questions. Go ahead, Lydia.
Cool. Can everybody hear me if I sit much closer to the microphone? So I think what we're gonna do is we're gonna have kind of more of a conversation where we're gonna talk a little bit about the different components that we've been involved in. And then just kind of wing it from there. But before we do that, I think we'll go through and give everybody a chance to introduce themselves and kind of the project, the case study that they're going to predominantly be talking about that's related to Planet Texas. And I think there was an ideal order to this, which was kind of, you know, community knowledge, the scientific data, and then the computational models part. But I guess we can start on the end with Casey. I think it's on.
All right, there we go, it's on.
So give us an introduction to who you are, what kind of research you're doing, and then what this specific project is that you've been working on for Planet Texas.
Wonderful. Wow. Hello, everyone. I was hoping not to go first so I could mimic, you know, the level of detail, but I'm ready for this. Let's go. My name's Casey Faust. I'm a faculty member over in civil engineering. The area of my portfolio that really overlaps and be talking today is the integration of community knowledge with pertains to operations and management of our infrastructure systems. So based on my background, one of the problems and one big area of my portfolio that I'm really interested in is when our infrastructure systems are pushed out of design tolerance due to contextualized conditions. That can be things like workforce, supply chain constraints, just really places that are really hard to operate our systems. And in those places, community knowledge becomes really critical. And so what I'm going to be predominantly talking about today is work that we have been doing in Alaska since, I want to say 2020, so about 6 years. And here we've been working out in rural and remote Alaska, so in some villages that are very remote. They have to take small puddle hopper planes out to, and you can get weathered in very easily, very hard to reach. And, some of these have, one of the ones that we're working with the most closely, probably about 600 people. And some of these, what we call hub communities that serve those individuals. And because of that workforce capacity issue, as well as the overlying governance between city and tribal governments, the community knowledge and operations becomes really critical in maintaining the functionality of these systems. And so one of the things that I actually came to Suzanne with probably right around there said, we have this challenge here where we need to figure out how to turn qualitative understanding, qualitative stories, experiences, knowledge into scientific variables that we can actually design engineering systems for. And some of that can be due to language barriers, it can be due to education barriers, just an array of problems that pertain to the human factors on the ground. And the challenge with this is if anybody here is familiar with qualitative analysis, to do it well is really time consuming and labor intensive. From everything from actually designing the protocols, getting ground, talking to people, as well as doing the analysis and then reiterating and turning that into something meaningful in terms of scientific variables to use for design. And that actually became one of the things we really wanted to tackle is how do we turn this community knowledge into scientific variables in a way that we can meaningfully use to provide feedback to our technical systems, because if we are just relying on numbers, we're missing a lot of the operational parameters where systems fail, whether that's at the workforce or the socio-technical interface. And that scalability became very important. And so it's something we've been working on for years is trying to talk to people, take those narratives, as well as things like regulations that maybe don't work up there, and just these different textual understanding of the situation, and turning them into something meaningful that we can use for management. And so I'll be talking a lot about how we have been managing to do that. And we've been doing that in a few different ways. Some of those is through turning these lived experiences and knowledge into usable training materials. Other times it's been semantically linking this knowledge and prioritization of different stakeholder groups to asset management decisions with our drone data of our communities. Other ones we're looking at is how do we some of our workforce management opportunities for improvement, and how do we design models and constraints and more mathematical representations of these problems using human knowledge. And so how do we, basically at the crux of it is, how do we take these narratives and turn them into something usable for engineers to be able to design on and scale it so that we can actually digest that data, and even though there might be a little slight loss of information from the qualitative analysis, be able to turn that into something that we can use, and so we can better operate our systems. Yeah, go for it.
Okay, thanks. Hi, everyone. My name is Pavel Misztal. I'm an associate professor in the same department as Casey. By the way, Casey, your work is so cool. You shouldn't have put me after Casey. So in my lab, we look at the novel air quality measurement techniques. We look at composition of the air and what we humans get exposed to. So I will tell you something. With each breath we take, we inhale thousands of different molecules and compounds that we've only recently started to be able to see. And there was a lot of talk in previous session about sensors, about low-cost sensors. So guess what? In my lab, we have a high-cost sensor. And this high-cost sensor, it's relative, by the way, because if you are a billionaire, maybe 1 million is low-cost sensor. But the nice thing about the instrument, the name of the instrument is Focus Proton Transfer Reaction Time-of-Flight Mass Spectrometer. I know, it's a long name, so we like to call it the sniffer. And the first thing in my lab we've been wondering about is, how does the air quality change in a city like Austin? So basically, I put the sniffer into my own SUV. Basically, I figured out how to connect the power and everything. Turbo pumps were not happy initially. The inverter was not pure enough. I changed the inverter. It took some time, and eventually we made it work. We were driving through Austin. I was so excited because I could see compounds coming from the airport, from jet fuel. You can smell jet fuel. You immediately see compounds that come off, like aromatics, like different glycols as antifreeze, and so on. You can see sources through the lens of chemistry. We were so excited. And then I bumped into Kerikini, who a lot of you know. And she was, if you want to see real pollution, go to Southeast Texas. And this is what I did. I drove all the way to Beaumont. And at that time, we didn't have yet this Southeast Texas project that Patrick spoke about, but it was mind-blowing. It was like science fiction movie. It's a chemical plant next to chemical plant, elastomer industry, paper mill, and so on. So the smell, odor was incredible. And then I realized, wow, this is a really important place because communities live here. And then we started this project, Southeast Texas IFL from DOE, to basically help communities who live, who basically have challenges. The challenges they put between flooding and air pollution. So two different stressors. So this is just one example, but we've been like, now we have the mobile sniffer van. It's a fully electric Ford E-Transit van. And we took this van to many different places, LA fires, across Texas, in California. And we collected so much data because guess what? As I mentioned, it's all relative. 1 second is real time, so 1 second might be a short time for modelers for who hourly or monthly data is pretty high resolved. Well, for the instrument, 1 second is like 1 million years because we are talking about nanoseconds. So the instrument measures time of flight of molecules, and you can tell chemical formula level identification. You can see basically all chemistry in real time. So long story short, Suzanne connected me with Will because she noticed that I was like we were using actually gaming workstations with my students, not necessarily to play games, but to actually crunch all these complex chemical data. So we got almost 0.1 petabyte of data so far. And when Will Mobley, who works with Suzanne, visited our lab, we were kind of bragging. We were like, look, we were measuring fluxes at Yale Coastal Field Station, and we processed them in 2 months on gaming workstations. So Will looked at me and said, how about 2 months? How about 1 minute on a supercomputer? I was like, wow, that would be incredible. So we started working together, and basically the tool we've been working on together is so cool because it comes from this Planet Texas 2050 effort, and actually it can be applied to everything. We're actually thinking about a ChemVOC community tool that basically everyone can use, and you, instead of feeding the data through the gaming workstation, you can simply go to the website and use the cookbooks and other things I can tell a little bit more later. It was, maybe I will stop for now. Yeah.
Okay, well, I mean, this is very apropos because the things that I deal with, I work with Will also at TACC, and we deal with big data, and the data set that I've been particularly involved in with respect to Planet Texas was the LiDAR data set, which can be quite large. We have an archive of the LiDAR. Everyone knows what LiDAR is, I assume. It's a laser-based elevation sensing. In this case, I mean, it can be ground-based, but it's typically, in this case, aircraft-based. And they'll do these flights, in one line, and then come back and kind of cover an area, and that'll get billions of points. It's called a point cloud of where the laser will hit the surface and then reflect, and then that's measured by the instrument, and you can get a very high resolution and high accuracy elevation. Of course, there are problems with that because there are trees and buildings and water, and so the bounce back is characterized or classified into one of several categories, and so ideally you can remove the trees and the buildings and ignore the water. Water has a very characteristic kind of return signal, and then create a bare earth product that can be then used for things like flood modeling. And so the actual LiDAR files themselves are enormous. And we kind of boil those down, we process them into a digital elevation model, which is still quite large, but much more manageable. But not really manageable enough, because it's not the kind of thing that you can put on a website and say, go ahead and download this 30 gigabyte file, because it will almost invariably fail at some point in the transfer. And so DataX is the sort of portal. Well, there's a couple of things here. One is the size of the file. There's also the organization of the file, because one is processing, creating products here and there, and one might have trees and the other one might not have trees, and this one is of this county and another one is of another county. But in order to make that useful to people, to make it reusable, because a lot of effort went into producing these products in the first place. In order to, you need some kind of a portal, some kind of a tool that will facilitate the acquisition of the data on the one hand, and very much as important, to provide the metadata associated with it. So how is it created? What exactly were, for example, the classifications used to produce it? Does it have trees? Does it have buildings or not? when was it made? What's the resolution? All this metadata that enormously improves the value, increases the value of the underlying data itself. So yeah, that's kind of the that's really the challenge, is to make this data reusable and generally available.
And I think that's the part where I come in. So my name is Lydia Fletcher. I work at the Texas Advanced Computing Center with Suzanne and Tomislav and Will. But my background is in actually the UT libraries. I have a master's degree in library and information science. And so my expertise is really in organizing and describing things. Used to be books, now it's data products. And so yeah, it's figuring out how can we capture enough metadata that accurately describes the data product that we're trying to give to people, so that scientists down the road can pick it up and do something with it. There's, in kind of the open data, open science world, a term, the FAIR principles, which is findable, accessible, interoperable, and reusable. And the idea is that it lays out a set of standards for creating metadata that enables you to describe a data product or some other kind of digital object in a way that, you know, in 6 months, 3 years, 5 years, when you've moved on to another project or grad student has moved on to another project, someone else can take this data and do something with it. And so that's a big part of kind of, we have this pipeline of, we're gathering data through, you know, community interactions, we're analyzing that, turning it into some kind of standardized quantitative data. In some cases, we have sensor data, which starts out as quantitative. We have these complex point cloud data sets. And then how do we publish all of that and get it into other people's hands? I think the next slide is yeah. So at TACC, one of the things that Suzanne really spearheaded was creating this portal called Planet Texas DataX, PT DataX. That seems right. And it's a combination really of a place where people can upload their data and store it on TACC's storage system called Corral. They can interact with the data there, share it with other coworkers, you know, things like that. They also can create what we call cookbooks, which are basically like Jupyter notebooks that enable you to create a program, run a large language model based analysis of an interview transcript, things like that. So I completely blanked on where I was going with that, but I'll turn back around. And one of the things I think we wanted to talk about in this session was how do you interact with the portal DataX? What kinds of things are you putting into it? What kind of things are you getting out of it? How has it enabled some of the research that you're doing? And then also talk about, I guess at the end, how do we make sure that we're getting the data that we're creating into the hands of other people who might be able to do other interesting analyses with it? So I don't know if we want to reverse chronological order this time. I'm going to make Tomislav go first this time. Give Casey a break. I could see her over there going, oh, no.
Well, yeah, as I discussed with the LiDAR data, I really just need a place to park large files so that they can be accessible and findable by anyone who needs it. You know, I work on another project. It's not technically part of this, but I think it's maybe worth mentioning, called ISOBank. ISOBank is sort of modeled. It's on the idea of GenBank, right? So anything that you have these instrumentation. Spent a lot of money, a lot of effort to go collect this data. Obviously, it'd be nice if it's generally applicable to be able to allow other people to reuse it. So GenBank sort of pioneered this with gene sequencing, right? The idea behind ISOBank is to gather the stable isotope measurements that people do all around the world, and again, bank them in a similar sort of way. Same idea, make it findable, make it searchable, and retrievable. And critically, with detailed metadata about what it is. Is it a walrus tusk? That's a real one, sorry, a walrus whisker, one I particularly remember. How was it collected? How was it processed? How was it prepared? Right, and then of course the actual results of nitrogen. Nitrogen. I forget the isotope numbers, but the normal kind, then the ratio to the rare one. So anyway, so that's isobank. LiDAR is exactly the same kind of thing, and genes and so forth. And so that's really what I'm looking for out of the DataX portal and PlanetX, is to be able to park my data somewhere and make it accessible and reusable in a way that the researchers can trust that they know what they actually have there, and it's not just some random intermediate product that was made at some point. They have they can audit the provenance of that data.
I was going to say, Pavel already threw out that he uses cookbooks, so I'm excited to hear what he has to say about the specific cookbooks that you're using and your experience with being able to build them, use them, things like that.
Yes, I will follow up on those cookbooks, and the product is also super useful. We're so lucky to have at Texas Advanced Computing Center, TACC, and what I often tell my students and colleagues and others, we should automate everything, literally everything, because we don't have 100 years to go through manually through different compounds or other things. And we are discovery oriented. So we like to discover different, basically address different big research questions. And a lot of sources emit so many different compounds. So basically, the saying, you don't walk in the same water twice. I'm saying you never inhale the same air twice. And what we want to do, we want to fingerprint everything. And we actually already have a database of thousands of different fingerprints. For example, we drive the mobile van. Let's say we have a source, some kind of chemical plant, or it can be something else. And when the wind is blowing horizontally, we can go around the facility. We would cross-section the plume. The van is electric, doesn't have a tailpipe, so we can sit in the plume. We can see exactly that signature. And then we can see how the signature changes as a function of different processes. Another big source, actually, in terms of air quality, one of the major sources is combustion. And you have heard about wildfires and wildland urban interface fires, which are quite relevant. So let's say someone in my group, I have some group members are here. Let's say Sam developed a method to analyze wildfire smoke. And basically, this can be translated to the cookbook. So if any of you are wondering what those cookbooks actually are, so imagine you are the chef and you get a shipment from farmers all around Texas. And these are completely unlabeled ingredients. So what you need first to do, you need to label everything, geocode it, where did it come from, and so on, and then basically have a recipe to do something like that. So the processing of the data, like VOC data that we specialize in, is actually extremely complex. It's a multi-step process. It takes a long time. But if you have a cookbook for every single thing, like wildfire smoke identification or fingerprinting and adding to database, now we are working on something that could see similarity. Like there's a real fingerprint. You just from the fingerprint, you can attribute it to a person because it's so unique. With the chemistry data that is so highly resolved, we can also find similarity score, like cosine similarity score and so on, plug in those cookbooks. And what is beautiful about those tools is that it's a multi-tier system. Like you can have one tier is for advanced users. So you basically, it's password protected and you can change things. And then you have a tier of, general community, for example, who can have digested data, geolocated. They can click, they can see, for example, where benzene was the highest. And things change over time and in space. So with those tools and now AI-driven embracement of this chemical complexity, I think there will be a lot of discoveries in collaborations. I will let Casey jump into some.
You know, when Suzanne asked me to be up here, I said, I really shouldn't be up here. My students should be, because I am really a glorified assistant and cheerleader for them these days. I feel like 90% of my job is writing emails, and they're the ones that are really in there on the day-to-day. And I have this crazy idea, and I tell one of my students, PhD students, Anna, who'd be much better up here than me, and I said, I want you to figure out how to automate this, to scale this. Go use the DataX portal, go use some of these workflows and tools with Suzanne and figure it out. And she's like, cool, okay. Comes back and does a better job than me. So when we use this, most of this actually, to be truthful, is being used through my students. I want to make sure that it's really clear. And then they sit down with me during our meetings and show me what they're doing. Like they get to do the really cool work, and I get to throw out ideas where they stare at me with a straight face and say, yeah, I guess we're going to try to figure that out. Cool. And so the way my students have been using it mainly is, let's start at the very, very beginning. Even before my students, last summer, I want to say it was, 2 years ago, 3 years ago, Suzanne and I went out to a very, very small village in Alaska. She said it was the most remote village that she's ever been into, and she did a lot of work in the Atacama Desert. She got dropped and she said, this is not what I expected. And we stood there, and she was trying to figure out a way, because one of my biggest fears is we get all this data, and somebody steals the drives, or I lose them, or they break between the village and I get back to UT. And that was a big problem, because there is no internet out there. There's no stable internet. Like, I go off grid, I tell my husband, I've got a satellite phone, but that is it. I'll see you when I get back. I hope everything's fine. That is it. Bye. And so we are completely off, like you are off grid, unless there's a serious emergency. And so we're out there, and she's going through it step by step, watching how I collect data, where I store it, how I'm putting it here, how I'm putting it here. And she's working with me to figure out the flow on how do I get these data in these really remote, ill-connected regions. There's some Starlink out there now, but even that's not always great, because you need reliable electricity, which is not always the case out there, and getting that back to UT. So that's one of the most critical things. We're talking about, a lot of people are talking about analysis, but for me, it's making sure that my data is protected first and foremost. And I'd be sitting there, and I'd be going through my process, and I'd be like, look, it broke again. Look, it broke again. And Suzanne's trying to fix it, and she's taking all of these notes on every step I'm doing as a researcher out in the field. And I'm like, can't upload it, it failed. And then we should be taking notes on all my workarounds and being like, okay, first I went to Google Drive, then I did this, and just trying to figure out everything within IRB. We're also dealing with sensitive data, so we also have to deal with IRB. And so she literally started with me there and followed me on as a researcher to say, how do we get this from super remote data collection, where we are off grid, to UT to keep that data safe? So that, my biggest fear that everything breaks in all 6 hard drives. I said hard drives in everybody's different bags. We have duplicates, and I literally separate them in case somebody loses their bag on the airplane. Because I was like, I did not spend all this time out here for nothing. And so that's the first step. And then my students get back, and once we're there, we do it. There's a couple of different streams of work that they're primarily doing. One of them is trying to automate the narrative analysis to meaningful scientific variables. So what we're looking is, right now we are comparing by hand coding the loss of information, but the gain in scalability between the automated processes that this tool provides versus the hand coding, because that scalability means that it's accessible to more communities. So even with the loss of information, if we can do this, we can make this knowledge attainable to actually design our systems to be better operated. And that's I cannot even emphasize what a really big deal that is when you base your systems on human knowledge. Like, example that hits close to Texas home, I was just out in Kerrville, and so another project that I have with Suzanne and Carrie Stevens here is we're looking at how to improve evacuation outcomes for Kerrville. And we were talking to some individuals, and some of the people who evacuated early, we asked, why did you evacuate early? What was the cue? And the one that's sitting with me that I can't figure out how to use is they said, the river sounded odd. 30 years I've been there, and it sounded odd. I've never heard it like that. So they moved 300 people at 3 a.m. because the river sounded odd. That experience matters. That matters, and it complements the passive technology, but we need to figure out how to take informed knowledge of our contextual situation to turn it into scientific variables for design. That's one I don't know how to use yet, but it's just a very stark example that hit us right here, home. So that's one of them, is how do we do that? The other one that another one of my students is doing is processing lots and lots of drone data. So a lot of these villages, they don't have the capacity or to do asset management with the workforce they have there. And they also have a hub and spokes model where they have a remote workforce. So for instance, there's not a certified operator running the water treatment plant. The data is transmitted to a hub location that is a plane right away. And if something breaks, everything stands still until they can get somebody flown out. And you might not be able to if it's the weather. And so, because that's just the way it works out there. So we're looking at ways that we can create digital twins to actually update remotely as well as make asset management decisions there. But so much of that is based on human knowledge. So not only do we need a way to take this rendering and update it based on something that's very dynamic with climate change and melting permafrost, and the conditions are always changing, but we also need to overlay that human knowledge on it, because the local indigenous knowledge understand, like they can point to me and tell me when where there's going to be an ice jam, where there is going to be a problem, where the permafrost is going to thaw more this year. And we need to be able to get that knowledge into our asset management decisions and understanding. So working on how do we not only process this mass amount of data, these drone surveys we're doing, but link that with the community knowledge and the priorities of various stakeholders, such as the city and the tribe and the children and the teachers. And how do we bring that all into one model? And we're working on that right now, and it's actually, I think it's got a lot of potential for inward-facing decisions, as well as outward-facing communication of things like climate change and how priorities change amongst stakeholder groups. And so it's got a lot of value, but that's all. So I guess we're using this from the very beginning of not to lose data while we're out in the field, which I actually think is the most important one out there. Because like the analysis is great, but only if we don't lose the data. So for me, that's the biggest thing. And then my students are using it for all this one, and I get to look over their shoulders and be like, this is really great. Now do this. And then they just stare at me and say, okay. And so that's, I'm doing really cool work through them, and they're so much fun. But I will say, throw out to Suzanne for, sitting there and tracing out she had a name for it. What was it called? Where you did the data tracing thing. But yeah, from like when I gathered it all the way to how I got it here. Huh?
It's called provenance.
Yes, that is it. That is it.
Yep.
And she was so patient. I just kept breaking every system she tried just to show. And it was, that's probably one of the most valuable pieces of this, is actually the remote data collection security, to make sure it's someplace. And I have peace of mind as a researcher that it is not lost when I am somewhere that is not connected offline. So.
Yeah,
anyway.
I'll follow up on that with a couple of things. First, I mentioned earlier that the storage system behind Planet Texas or PT DataX is our Corral storage system, which is a currently tape drive, future flash-based storage system that backs up to a magnetic tape system called Ranch. So the data is really secure once it comes to Corral. Once it hits Corral, we got you. The analysis components, the cookbooks in PT DataX run on some of our high-performance computing systems like Longhorn, Stampede 3. I think some run on Frontera, which is our flagship NSF system. So yeah, the computing time to do some of these analyses, we can cut it down from like 2 months with a bunch of laptops rigged together to an afternoon. So it's really incredible the way that Suzanne's team, the actual developers who can build the things, have integrated all of these things together. The other thing I will say is, before you guys went out to Alaska that summer, we went out to Fort Davis in West Texas and kind of did a trial run of all of the systems that we sent up there, the Starlink and the drones and everything. And we had a really interesting interaction with a person out there who we were talking about the 2011 fire out there that threatened McDonald Observatory. And the person that we were talking to, we were saying, how did you find out that the fire was coming and that it was moving so fast? And she was like, oh yeah, like my daughter called me and she had heard it from a friend. And so like the lines of communication of how the information spreads in some of these situations is so community-based, and trying to capture that in a quantitative way that you can, analyze and explain was very interesting. It's very fun. My whole job kind of out there was to think about like, okay, how can we, as we're gathering this data, we were flying a drone to capture topographic data. We were talking to people to capture kind of interview-based data. How can we describe all of this data using a standardized metadata schema so that it's, robustly described? How can we do that on the fly as we're out in the middle of nowhere with no phone, no internet, no nothing? How can we make that process both robustly descriptive, but also not such a huge pain that nobody's going to do it? It's finding that balance between, like you were saying, there's so much, you're in the field and you have such a limited amount of time in some of these communities because of, budget restrictions, weather restrictions, travel, things like that. You have such a small amount of time. You don't want to be sitting there, creating metadata the whole time. You need to find a way to automate it. Passing it to Tomislav.
No, you just reminded me of another project that I've worked on is called Paleo Core, and the idea is, so let me just step back a little bit. We've talked a lot about metadata and how great it is, and it is terribly useful.
Also a pain.
Yeah, it is also a pain, and people generally will, try to leave it till last. I mean, get the data in, and then maybe, add the metadata. But the point I wanted to make was the distinction between metadata in general, which, as I say, is certainly great and much better than nothing, and a metadata standard. So a metadata standard means that a whole community has actually agreed on which metadata fields are important at a minimum, perhaps, or extended to capture. So prominent example, I work a lot with natural history collections, and Darwin Core, well, actually Dublin Core is kind of the most basic generic data. This is a file, this is the date that the file was created, this is the type of file it is.
This is
Yeah, who?
I think my microphone went out, but
you're good.
yeah, Dublin Core is who created it, when was it created, what is it called, when was it modified? It's the most basic, what you would think of. It grew out of library catalog systems. What is the title? What is the author? When was it published? Who published it? Where was it published? The same stuff you put in your bibliography anytime you write a paper. And so Darwin Core evolved from that to be very specifically tuned towards biological data. And it, has a background in kind of the, what is it, kingdom, phylum, class?
Yeah, so the taxonomy, the taxonomic hierarchy, that's certainly a big part of it. Where did the occurrence occur? How is it vouchered? Is it a photograph? Is it a human observation? In museums, it's typically an actual physical specimen. And the beauty of these metadata standards, it's a little dry, admittedly, but is that now we can exchange our data in a way that doesn't require mapping of fields. It doesn't require me to go through 150 fields and say, oh, I call it this, but they call it this here, but it's the same. But no, maybe it's not quite the same. It's a little bit different. So the beauty of a metadata standard that can be agreed upon is this exchange, this interchange of data. The astronomy community has really pioneered this. It's a really small community. There's about, 800 professional astronomers in the world. And more?
There's like 2,000.
Okay. But the point is that it's a small community, and they were able to come to a relatively early agreement on their standards. And it's been much more challenging in the natural history space because people don't even agree on taxonomy. But Darwin Core is universally used, often needs to be extended, which is what the Paleo Core project that I was on was all about. It was to extend that to physical anthropology to early human fossils and some of the things that are specifically needed in that space. And you reminded me about it because the researcher Danae Reed here at UT Anthropology, who they go out to the field, typically in Ethiopia, and they are also relatively off the grid. They have these handheld devices and so forth. And the idea is to put literally as you're in the field taking data to immediately write that to the database with your PaleoCore standard. And then when you get back to connectivity, to store it in the database. But the metadata and the metadata standard are kind of baked in from the very beginning.
So I can. Is there still time, or?
We have about 15 minutes left, so I think if we wrap up and then give folks maybe 10 minutes to ask questions if people have questions. So yeah, wrap up thoughts.
Is it if I do? Yeah, is it okay? Sorry.
We have a special guest joining us at the table.
Can you do the wrap up thoughts?
So, no, I just want to first, let's see.
Here, this one's not.
Does it? Oh, this one's on. Yeah. So I'm Suzanne, and these guys have been the best of sports because I invited them and said, just have a casual conversation about this and let's see what comes up.
We use all the stuff that she builds.
Yeah.
But it's not me. So in 2018, when Planet Texas 2050 first began, the goal was, can we build a cyber infrastructure set of services that generically can help people with every kind of possible problem in their research and with communities that may crop up. So we have spent the past decade almost trying to build these general services that can be translated across any place and any problem. And so you heard people talking about how it's getting used today. It starts with, this is a screen capture of our relatively simple interface because it's not the bell or the whistle. This is the engine that can help people drive their research faster and accelerate them to useful outputs. And so we want you to be able to share your data, to reproduce your workflows. We want you to be able to access it simply. So you've got this data discovery tool that metadata and library and information sciences has helped us make real. We've got the upstream service that helps anybody who has small tail data. So if you have sensor data, if you have small sample size data, if you have massive data, just like Pavel has, then we're able for you can load that in from remote places in the field, and you can see that temporal data, and you can look at the uncertainty brackets on it, you can see it on a map, and you can look at things and create your own collection. So it's very composable. And then if you look at the map services, we've got this open drone map tool, and then just as Tomislav was talking about, we've got the entirety of the state of Texas LiDAR collection sitting at TACC. And so it took about 15 days to transfer that data from the Texas GIO offices just to move the data over. And if you go to them today and say, I've got a project and I need to get the data for my region, you have to pay to get that data. But we've already downloaded it and indexed it for you. So if you go in through our services, which is DataX, the portal, the center point of it all, you can get to that data and information. And Tomislav is helping us figure out how to make that simpler. And I was trying to keep the slides simple, and Lydia and I didn't have much time to coordinate, so we kept it very simple. But once you log in, that's when you get to these magical things called cookbooks, where you can create your own reusable analyses, and that's what Casey's team is using now. And we're loading our data in from the field, and in the case with Casey, we load it into a safe space where you can take interview information from sensitive communities, and you can transcribe it with the click of a button, and it comes back around, so it tracks the provenance, it comes back and it's registered. It's not exposed, but people who search with keywords, if they want to see, has anyone done any work with the Arctic region in a village, do a keyword, you'll see there's a registry that says, oh yeah, this data exists, and who can you contact to get access to it? If it's publicly available, then you can just see it, but the researchers decide what is and is not visible. And then we also, thanks to Casey's group, we're doing these analyses where we're semantically linking the data to the models and the analyses. So when you say, I need to run a rainfall forecast, it gives you a recommendation of which data sets are in the data discovery tool that can be used with which forecast models that are registered in our model management system. So it's kind of, it doesn't look very sexy. I'm sorry about that. But it does all the hard work. So, and these guys are the best of sports because talking about something that generic and that abstract, if you haven't been working on it since 2018, is really hard. But these are the groups that are making it happen for us. And without these 4 people in particular, we wouldn't have gotten this far. And so I'm really grateful to everybody who's up here.
So we do have, I think, about 8 minutes left now officially. So quick.
No, I think that was good. I think we should stop right there on a Q&A.
I've got a pretty basic question, but Casey, I'm just curious, when you're in the field, are you doing interviews and recording them, or do you have portraits for them?
Yes. I would say it's, what are we doing out in the remote? We've got interviews. We have, sometimes we're doing surveys.
You're recording it like
We're recording it on, well, a couple different devices. We are usually using a recorder for that with a lavalier. We usually have a voice memo backup because, again, if that fails, like, you know, it's not great to get data from elders multiple times, so we make sure we've got redundancies. And then we have surveys that we've done in the field. We've done water quality sampling.
paper or portraits?
Both. We, I would say we always have both. Most of the communities we're working with prefer paper. They don't like working on electronic versions. So what that usually will mean is that they fill out the paper form, then somebody goes and inputs it into the Qualtrics themselves. But they're usually both available. But I would say 90% of the time, somebody in the communities we work with would rather have pen and paper. So then we take that back, we immediately put it into a form, and then we keep both, obviously, but you know, you don't want just your paper one to be the only one you have. So we also have water quality sampling that we've done. We've done a lot of drone data we've collected, a lot of operational logs, utility management logs. A lot of this is still paper-based, so people will like literally be like, "Oh, you're looking for this here," and then hand us a stack of printouts, and I'm like, "Cool, we're gonna go handle this right now." And so we get a lot of digitization that we've been doing for paper logs. So did I miss any other data? That's pretty much kind of the ones that we've been working with lately, right? Yeah, I'd say that kind of.
It's extremely similar in context to the work we're doing in Kenya. I would love to chat.
Yeah, absolutely. And I would love to do work in Kenya, so you know, let's figure that out too.
Yeah, so, you know, before we continue with the Q&A, Suzanne wants me to point out that we, at TACC, we host a variety of summer institutes over the course of the summer. They're paid for workshops, usually 4 or 5 days. Suzanne's hosting one this year. This is the information about it. If you're really excited about the data curation part and you really want to learn a lot about metadata in Darwin Core and Dublin Core, I'm also teaching one this summer. It's the week after. So see me for details. It is kind of summer camp for grown-ups. You get to come hang out at the Pickle campus for a few days and learn all kinds of cool skills. They're super fun. But yeah, so we can move into taking some questions unless you guys have like burning things. I know, Pavel, you almost said something before Suzanne came up.
Sorry. Do you remember what it was?
Do you remember what it was? Do you want to share that thought?
Is that thought gone? Is it still here?
No, it's still here.
Okay.
I just wanted to say that the capabilities that we discussed, it's just a fraction of what is possible with TACC. Not only these examples show like applied research and community interactions, but also I feel like it has potential for advancing our knowledge and understanding for some fundamental research and like we're talking about drones, like you're talking about these things, and we were the first to actually try the sniffer with the drone. We connected the inlet, and then we realized it's actually 8D. Why it would be 8D? Because you have like X, Y, and Z dimensions. You have time, but then you have concentrations of many different compounds, reactivities, odor activities, and abundance. So basically, we have been creating this framework. And one final thing I want to say, like, if you are interested in factors that affect human health, one important thing to understand is that we spend 90% of time indoors. So a lot of research has been focused on relatively clean outdoor air. The level of organics indoors is like 2 orders of magnitude or more. So
That's your closing thought.
it's really, yeah, so the closing thought is like we should map out and all these houses and fingerprint and understand human exposure. But yes, enjoyed the panel with you all.
This is very terrifying closing thought.
Everyone buy an air purifier. But are there any questions in the back?
No, I'm just passing out the remote, the mic for others.
Okay. And yeah, to follow up on what Pavel says, you know, at TACC, especially in the group that Tomislav and I are in, our jobs are basically just partnering with research projects and helping them to make things happen. You know, Tomislav builds a lot of databases to help people store and share their data. I help figure out what's a good way to do that. But we're always excited to work with people. I'm especially excited to work with people. So if you have a grant coming up and you need help with your data, come chat with us.
I have two quick questions,
Yes.
hopefully quick. One, I guess, what advice would you give to someone who just wants to get started potentially using DataX, but might feel like overwhelmed by, you know, the capabilities that you've shared, or just don't consider that, like, I'm a qualitative researcher. I've told Suzanne this a million times. I'm like, this is so cool. And I could explain it when I walk out of this room, but then 5 minutes later, I'll be like, wait, what are all the things we could do? Okay, so you're saying the Institute,
Come to our institute.
Informed Integrated Decision Support, is how to get started.
That's great.
Part or all, you can drop in.
I have a detailed schedule that I'll send to y'all, and it will be circulated through PT 2050. And PT 2050 is the whole reason it exists, so we're saving
Whoop.
seats for you all.
Yes, and we can also help support people who would like to attend.
Yeah. Yeah, the institutes are a great way to get started. And also, in order to log in, you need to create a TACC account, which is a super easy thing to do. You know, go to the TACC website. The steps are fairly straightforward. And then once you get set up with that, do they need to request access through? Well, we'll figure that out.
The DataX allocation.
Come to the institute, and you'll get all of that set up for you. Or reach
I
out.
didn't actually mean to set you up so perfectly to promote the Institute, but it just worked out that way. Last question, and then we'll thank our amazing panelists. Oh shoot, did I forget what it is? It's gonna come back, it's gonna come back. Oh, I remember. I work a lot with the city, both through PT 2050, but also through the interlocal agreement, and they're always trying to get their, like, data house in order. What is the availability of TACC resources for non-UT municipal partners and others whom we work with in other parts of the state?
Yeah, so we generally have, you know, primarily our funding comes through the National Science Foundation. So the majority of our partners are folks who are getting funded through NSF or through DOE or things like that. We also have a program that's called the STAR Partners, and I could not tell you what STAR stands for, so do not ask me. Science, Technology, and Research.
That's a pretty good acronym.
It's great. And those are, we work, some of them are private companies, some of them are state agencies, like the Texas Water Development Board is a STAR partner. So those are kind of outside of the research or outside of the academic sphere. Those are other partners that we work with. I'm not sure, there's a fee that they pay to get access to our resources, and then that gives them a level of time on the computing machines, you know, storage on our storage system, things like that. Yeah, access to the folks at TACC who can help them, you know, develop their code, you know, things like that. So there's that level. And I don't know the full details. I probably should. I work with those folks. They're great. I usually just get an email and they're like, hey, I'm a star partner. And I'm like, cool. I'm free then.
So you're saying there's a chance?
I'm saying there's a definite chance.
We can follow up.
If you bring TACC
I
money,
see County smiling.
if you bring TACC money, we are happy to work with you.
Thank you. All right, y'all. Thank you so much. That was great.